We just did a whole bunch of things with a particular position function. We're going to do them all over again with a new position function. So this position function is a little bit more complicated. It involves a trig function. So position as a function of time is sine t plus 1/2 t. We'll suppose that again we're measuring time in seconds, position in meters, and we're describing an object that's just moving back and forth along some horizontal line. Okay, what I'd like you to do in just a moment is calculate for me the velocity, acceleration, and speed. Remember, absolute value of velocity is speed. And then calculate the displacement and the distance over the time interval that we're concerned with. We're just concerned with the time interval from 0 to 2 pi. Displacement, remember, that's just a subtraction problem. Ending position minus starting position. Distance, on the other hand, for that, you're going to need to take into account both the position and the velocity. You're going to need to check the sign of velocity and break this time interval up into subintervals where the particle is moving to the right with a positive velocity or moving to the left with a negative velocity. Over each of those time intervals, calculate the absolute value of the displacement and add those up to get the distance. All right, go ahead and try that. All right, I've filled in the formulas for velocity, acceleration, and speed. I think those were pretty straightforward. Derivative of sine t plus 1/2 t is just cosine t plus a half. The derivative of that is negative sine t, and that's our acceleration. And speed is just the absolute value of the velocity function. Now, for displacement, remember we said that's just a subtraction problem. So we're going to calculate our position at 2 pi and subtract our position at 0. Ending position minus starting position. The position at 2 pi is sine of 2 pi plus 1/2 of 2 pi minus the position at 0 is sine of 0 plus half of 0. Now, sine of 2 pi is just 0, half of 2 pi is pi, minus sine of 0 is also 0, and half of 0 is just 0. So we get pi. Okay. So that's the displacement over this time interval. So wherever we start, and it looks like we started at position 0, we're going to end pi meters to the right of that. Okay, now for the distance, that's going to require that we break this up into subintervals. So I need to take a look at the velocity. That was cosine of t plus 1/2. Now that's always defined. What that tells me is that the only times this can change sign is when it passes through 0. So let's set that equal to 0. Now that would mean that cosine of t is negative 1/2. I can either look at the unit circle for the places where the x value is negative 1/2, or I prefer to do it, I'm more of a triangle person, so I think if cosine is negative, I know that's going to put me in quadrants 2 or 3. So we're talking about a t value here or a t value here. Both of those will have a reference angle that I'm just going to call alpha, and I know that cosine of alpha is just the absolute value of this. It's got the same absolute value, but it's got to be positive because alpha is just an acute angle. So we're looking for the acute angle that has a cosine of 1/2. If I know my 30, 60, 90, and I do, I can see that that's going to give me an angle of 60 degrees. Of course, we're working in radians, so I'll convert that to pi over 3. So here, t is pi minus pi over 3. That would be 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. Here, t is pi plus pi over 3. That's 3 pi over 3 plus 1 pi over 3. So that's 4 pi over 3. Okay, so I'm going to draw myself a number line for the velocity. Okay, and I'm going to mark off these two places. 2 pi over 3 and 4 pi over 3. Now, I didn't bother to draw this to scale. Good enough. Those are my subintervals. I did not attempt to draw this particularly to scale. Okay, but I want to see the sign, oops, there's no bar there. I want to see the sign, plus or minus sign, of the velocity over these time intervals. Okay, so I need to just pick a test number. Okay, so let's see. I'm going to just pick, I think here, 1 copy of pi over 3. And if I plug that into my velocity function, cosine of pi over 3 is 1/2 plus 1/2. That's just 1. That's positive. Now, between 2 pi over 3 and 4 pi over 3, I'm going to pick pi. I like to pick quadrantal angles when I can, and I can easily see that when I pass from quadrant 2 to quadrant 3, that's going to involve passing through pi. Okay. I suppose I could have here actually chosen pi over 2. That would have been a convenient quadrantal angle I could have chosen. Okay. Cosine of pi is -1 plus 1/2. It's still going to be negative. So the velocity does change sign, which means that the particle changes direction. Okay, so it starts out going to the right, then it changes and goes to the left. Let's see if it changes again. I am going to just choose a quadrantal angle here. I'll choose 3 pi over 2. There, cosine would be 0, plus 1/2 is positive. So we do, in fact, change direction again. So we go right, then left, then right. Okay. So let's calculate the total distance that's traveled. And in the process of doing that, I'm going to be calculating the position at these times. I'm going to just record all of that information up here, because eventually we're going to be drawing one of these diagrams and we'll need to know the position at these important times. Okay, but for the distance, I can basically say that's going to be the sum of 3 things, each of which is an absolute value. It's the absolute value of the displacement over this interval, and this interval. So over this interval, we would have the position at 2 pi over 3 minus the position at time 0. Over the middle interval, our displacement is the position at 4 pi over 3 minus the position at 2 pi over 3. Of course, I'll take the absolute value of that. And then over this third interval, my displacement is the position at 2 pi minus the position at 4 pi over 3. And again, I'm taking the absolute value of that. Let's just first of all write the positions down up here. Okay. So when I plug in 0, sine of 0 is 0, plus 1/2 of 0 is 0. We'd stated previously we were starting at position 0. And I believe we actually figured out that we were ending at position pi. We've calculated that when we calculated the displacement. So at 2 pi over 3, sine of 2 pi over 3, we're in quadrant 2, so sine is positive. The reference angle is pi over 3, or 60 degrees. So this is going to be root 3 over 2, and then plus 1/2 of 2 pi over 3. So that would be plus pi over 3. A lovely number indeed, but that's our position, 2 pi over 3 seconds into this problem. Okay, at 4 pi over 3, now we're in quadrant 3, so sine is negative. But we still have a reference angle of pi over 3, so the absolute value that we're attaching to that is still root 3 over 2. So this would be negative root 3 over 2 for the sine, plus 1/2 of 4 pi over 3 would be plus 2 pi over 3. Okay. So these are all of our positions at the relevant times. So now let's calculate our distances. So this is going to be the absolute value of, we said, root 3 over 2 plus pi over 3 minus the position at time 0 was 0. plus absolute value of the position at 4 pi over 3 was negative root 3 over 2 plus 2 pi over 3, minus the position at 2 pi over 3 was root 3 over 2 plus pi over 3, plus the position at 2 pi was pi, and we're subtracting. Notice I'm being careful about parentheses when I'm subtracting something with two terms. We're subtracting a negative root 3 over 2 plus 2 pi over 3. Now, I do have a little bit of simplifying to do, and I'm going to have to be careful about evaluating the absolute value because these numbers are a little bit messy. We'll survive. Okay, now this first piece, this is just a sum of two positive numbers minus 0. So that first piece simply becomes root 3 over 2 plus pi over 3. Okay. Now, this second piece, I'm going to just simplify that by itself. Absolute value of negative root 3 over 2 plus 2 pi over 3. I'm going to distribute that negative. Minus root 3 over 2 minus pi over 3. Okay. So let's see. These are both negative. So I'm just going to have a negative root 3 plus, looks like we've got 2 pi over 3 minus pi over 3 plus a pi over 3. So I need to know now which one of these is bigger than the other so that I know whether this was positive or negative. And there are a couple ways that I can go about doing that. One is, if this is take-home work, I could just use a calculator to get a decimal approximation. But the other thing I can do, and I think this is kind of cheap but easy, is I can say that was calculating this right here. That was the absolute value of the displacement over this middle time interval. Over this middle time interval, I know that my velocity was negative, so I was moving in the negative direction. That's going to mean that the displacement was negative. So this quantity inside the absolute values here is a negative number. Root 3 has a bigger absolute value than pi over 3 does. The negative part is bigger than the positive part. If this is a negative number, when I take the absolute value, I'm going to get the opposite of that thing. So I'm getting the opposite of root 3 plus pi over 3, which is just root 3 minus pi over 3. I'm sorry, I'm getting the opposite of negative root 3 plus pi over 3, which changes the sign of both terms. So it's root 3 minus pi over 3. So this was the absolute value of the displacement over the first piece. I'm going to add to that root 3 minus pi over 3, which is the absolute value of the displacement over the second time interval. And then I've got to add to that the absolute value of the displacement over this third time interval. I'm just going to clear myself some space so that I can simplify that. This is my running total of the first two things that contribute to the distance. So here, with this last piece, we're looking at the absolute value of pi, and I'm just going to distribute that negative. Minus a negative becomes plus root 3 over 2, and then minus 2 pi over 3. Okay. So that's going to be the absolute value of, let's see, the pi minus 2 pi over 3 is going to be pi over 3 plus root 3 over 2. These are both positive numbers added together. So when I take the absolute value, nothing changes. So we get pi over 3, oops, sorry, we're adding pi over 3 plus root 3 over 2. Oh my goodness, this is so exciting. Okay, so now let's combine things. I've got some root 3s, and some root 3s. Root 3 over 2 plus root 3 over 2 is a full copy of root 3, plus that root 3 is going to be 2 copies of root 3. pi over 3 minus pi over 3 plus pi over 3 gives me plus pi over 3. That, in meters, is equal to our distance. Okay, a lot going on there. We do need to remember that absolute values do not distribute over addition and subtraction. So we had to do the addition and subtraction first. If we got something positive, the absolute value didn't change it. If we got something negative, the absolute value told us to take the opposite of that.